So welcome back to the second phase of our prototyping phase. Now in the last post we saw how we segmented the customers using the RFM analysis and sorting and all this activity. So if you have missed that out, please refer to the previous post, and which is here in the descriptions of this video. Now in this post, what we will do is we'll take our segments forward. Now, as we discussed, the segments are our states for our for this recommendation engine, because we are implementing the recommendation system using a reinforcement learning problem, which is specifically K-bandit problem, and these customer segments which we implemented in the last post would be one of the components of the states, and we'll create other states also, and all together we will form one single state ID, which we'll see in this post. So let's quickly have a glimpse of what are those processes which we will implement here in this post. One is we will build this different states, and after the states are built, then we will build the self-learning recommendation part using the K-bandit problem, and then we'll also implement the customer actions, simulating of the customer actions based on which recommendation is done to give the feedback. So these are the various activities which we will do in this current video. So let's dive in. So before we dive in into the implementation part, let's take a look at some of our basic assumptions. Now we have assumed that customers in the same segment have very similar buying behaviors, and that's the rationale why we are making the customer segments, and which will add as a context. So any customers belonging to the same segment would have similar buying behaviors. Now the second assumptions which we are making is again, even the buying patterns vary across the months. So you have different types of buying patterns across the months. There's a variability, and which we have seen in the exploratory analysis in post 3. So you can refer to the post 3 where we did the exploratory analysis and how the average buying pattern in terms of the gross value of products bought was varying across the months, which is quite obvious, and that's why we are taking a month also as a context in which as a context for building our states. Another granularity which we are bringing in, it's not just the months alone individually. We are also making a division in terms of the period within the month. The first 15 days we are taking as one period, as a one specific context, and the next 15 days as the next context. So that granularity also we'll bringing, and we're still going granular from there, and we are also assuming that the buying patterns across the weekdays, whether it is Saturday, Sunday, Monday, whichever days is, those also there is a variability. So we are bringing 4 different types of hierarchies which we are bringing into the states, or that's the basis on which we are making the states. So maybe now to go forward, we can still go into much more granular levels. We can decide, say if we have more data in terms of even within weeks or within each weekday, say purchases which were bought before say 12 noon and purchases which was bought after 12 noon, or even from the customer segment perspective, rather than going for customer segments altogether, we can go individualized customers themselves, because that will get into a more personalized thing. But only problem here is number of states increases a lot, and which will become a little more complex, and we can do that when we get into say a deep reinforcement learning, where number of states doesn't matter and the number of actions which has been taken from those states doesn't matter. We can treat that within the deep reinforcement learning techniques, which will maybe obviously do it in a future post. But this specific series is about how do you implement that in a much more simpler pattern, simpler way, which is through the k-armed bandit problem. So that's why we'll restrict to the context to these 4 different hierarchies. Now from a data perspective, we have most of the data. We have the customer segment data which we did in the last post. We have the months which was generated from the data. We have the day of the week also we have generated from the data. Now we need an indication whether a specific date falls within the first 15 days or the latter 15 days. So that's kind of a binary indicator which indicates which period in a month it falls into. So we will get into next we will get into how do we implement that. It's a very simple implementation. Let's see that now. So let's get into this implementation now of extracting the periods, the first 15 periods and the next 15 periods of a month. So for this again we'll use the past date and the lambda function. So we'll create a new variable called the date, which is, so what we'll do is we'll take the past date which we have already found out, and then apply lambda functions. So here what we are doing is we are extracting the specific day or the date, say it's first or second or third. So it will, this percentage d here in this strip time will give you the specific day of the month. So we are storing that as a float. Now the last line is we are creating a new variable called the month period. So it will so we are saying that any date which is greater than 15th will be 1, will be a specific so if it is greater than 15 you will have 1, if it is less than 15 it is 0. So we are giving a binary feature for this month period, specifying whether it is greater than the 15th or greater than the 15th of the month or less than 15th of the month. So let's implement this and then see the data frame. So this is what we've got. So here you can see all those other features which we have already created, and then you can see the month period. So you can check the dates. So if it is less than 15th, the month period is 0, and if it is greater than 15th, the month period is 1. Now so now we have all those components of a state, which starts from the segment, then we have month, these binary month periods, whether it's greater than 15th, before 15th or after 15th of a month, and we have the weekdays also. Now we will slowly get into the core part of it, which is using these information to build our states. Now when we were discussing about the k-armed bandit and when we implemented in Post5 we saw that different functions were generating the rewards. We saw that rewards were non-stationary rewards, and then how that reward distribution happens. And then also we looked at the different values which were generated, which were trained for different arms, and these values were based on the update which we have done. Now there is so what we also found out that many of these values we used initial values as 0, and then we slowly trained them, and then finally got into the values. But here in this approach, or in our specific use case, we don't have to train them because we already have data about the buying patterns of these customers. So we don't have to initialize them to 0. So what we will use is the initialization values would be based on the current frequencies, buying frequencies of different products. So what we will do next is in this code is we will group all the data which we have on the specific states which we have. So we'll group it by first segment, then the month, then the month period, the day, and we will aggregate it with the stock code, that is the product which has been bought, and finally we will aggregate the quantities sum all the quantities according to these grouping, according to these hierarchy. So let's implement this, and then once we see the data frame, you'll get more insight to it. So this is the final data frame which we've got. Now let's look at it. We have around 264,000 rows, kind of rows. So each of this data point is according to our state. So you have a segment, your month, which is April. The first record is April. Month period is 0 because it's a date before 15th. Day is Friday. Stock code, which is a specific quantity or specific product, and the quantities. What are the total number of this specific product which has been bought, which is here, which is this. So for each of those states, according to the different different states, we see the aggregation of different products and its quantities across this. Now what are we going to use these information from? Now these information will be the initialization values for our reward and value functions. So we'll see how these becomes the initialization values for our rewards and value functions, because it's ultimately the quantities which has been bought. Now the assumptions which we are making is based on the quantities which is bought, that gives you the propensity of what products are more popular within that specific segment for that specific state. The amount of quantities which has been bought gives you an indication of the propensity for customers to buy that, and that's why we are aggregating the products according to the product code and getting the quantities for that. Now we'll get into seeing how we will use to initialize these initial values of the reward functions and the value functions.